Okay, so getting the timing right for the yearly record class is tricky. So I'm going to do a quick example with a slightly different method as an illustration of how you might approach this problem. So I'm assuming that you understand the timing for the yearly record class and what it's supposed to do, that all of this here makes sense. Okay, so to approach this problem, this is a very basic implementation of a yearly record. We create a map that maps from strings to integers, and when we want to add something, we just associate the word with its count, and we can return a count, right? I'm using a tree map, you can use a hash map, whatever, that's all going to be about the same. So here is a method that I'm going to add that's not part of yearly record called fewer z's. What it's supposed to do is, given a key, it tells you how many keys in the map have fewer z's than that key. And if something isn't in the map, let's say we put in peel, 5 z's, zebras, and zebras, we can look up, for example, 5 z's, and it'll say there are 3 keys that have fewer z's. This should return -1 because this is not part of the map. And then zebras with an S should be just 1. There's only 1 key here that has fewer z's than zebras. So obviously somewhat similar to rank. So let's try and write this thing the naive way, all right? So what I might do first now is say, I don't know, let's see. I need to return -1 if it's not part of the map. So I can say if the count map contains key X, if this is not true, I have all these parentheses, okay. So if this is not true, then we'll return -1. Otherwise, we'll continue. So when we continue, one approach is then iterate through all the strings and say count map.keys set. And then we might do something like the following. If s.zCount is less than x.zCount, then increment some zCount variable, and then return zCount when we're done. Ooh, but not there. Okay, so this approach basically should work, except that there is no zCount field of a string. So let's fix that by writing a helper method. So let's say private int zCount of string x. This returns number of z's or z's in x. All right. And I'm not going to go through this in detail because this is not really pertinent to what you're trying to understand. So I'll just fast forward, but you can watch if you'd like. So it might be something like this. All right, so we've written that. Let's see if it works. Oh, yeah. All right, so this is a basic approach. Now this isn't so good because of the fact that this fewer z's method is going to be linear time. But if it's going to be our stand-in for rank, pretending like it's kind of like rank, the trouble is that if I have something where I've put in 1,000 items versus 1,000,000 items, these calls should all take the same amount. That is, the number of the amount of time that it takes on a small record should be about the same it takes on a large record. So how can we do better? Well, one approach is, rather than recalculating the number of things that have fewer keys every time, let's just create magically a map which tells us how many things have fewer z's than the current thing. And then in the fewer z's map, all we'll just return the answer from this map and just say fewer z's.count, get our string. And as long as the map is accurate, then things should be fine. And then the job is just make sure that this map is always up to date. Okay, well, how can we do that? So one approach some of you guys have taken is in the put method, you can, for example, update fewer z's count. So this particular map, you rebuild it whenever you put. And so what I'll do now is just write a quick little helper method, well, somewhat quick, private void update fewer z's count, and it's going to say fewer z's count equals new tree map. So every time you put, you rebuild this magic list of all the correct answers every time you put, and that will mean this method's quite fast. Let's see how this we build. Okay, all right. Yeah, something broke. Okay, of course it broke because this wasn't in there, but it compiles at least. Okay, so how do we make sure that update fewer z's count works? Well, what we can do, I mean, one approach would be, this is the slow approach, okay, which I wouldn't recommend. Compare every possible, so for every key, compare against all other keys and count z's. This will be big O n squared, which will be slow compared to sorting. Now, I think this might still pass the timing tests. Be interesting to see. But what I'm going to suggest instead, better approach, sort the items. Okay. So in other words, what I might want to do then is I want to sort peel, ZZZ, zebras, and zebras. So after sorting, we get peel, zebra, zebras, ZZZZZ. So we're going to sort them by order of how many z's they have. Okay. Well, to do that, I'm going to take advantage of an array method called arrays dot sort. So I'm just showing you the way I would do it. You know, I mean, that's obviously going out into some crazy space, perhaps being hard for you guys to figure this one out. This is my personal approach to this kind of problem. So there's a sort method that uses a comparator. And so I could, for example, say arrays.sort all of my words by some z comparator. All right. So I guess let's do that. So let's think about words here. So we would need an array called words. So it's a new array of string that takes fewer z's count. Oops. Actually, that's not true. Count map dot size. That's however many things there are. And then we, for string w, say word in count map dot keyset. We will do words I equals word, and I can do string. I'd say I equals 0, I plus equals 1. All right. So this code here will set up an array words. This will sort it by z's. Okay, but we also need a z comparator. Well, that actually is pretty easy. So we do private void, private class z comparator implements comparator strings, and it needs a compare method. String x, string y, return x dot z, or sorry, z count of x minus z count y. And this, maybe we'll make a note, comparator that compares strings based on z count. Okay, so at that point, if we do this somewhat arcane approach, we sort these words and they appear in sorted order. So let's see if this works. So arrays.sort will system.out.println arrays.toString words. Okay? And again, I'm just coding as fast as I normally would. I hope it's not too scary. All right. So I think that's everything. So if I run this now, I'm just doing a little test to make sure it's sorting the way I expect. Okay, so we need to import Java util arrays. There are other ways to do this, by the way, but I don't know. I like this one. Okay, so that's comparator string. Okay, we also need to import comparator. Compare public. Okay, peel ZZZ, peel zebras ZZZ, peel zebras ZZZ. So it's sorting the way I want. So the last step then, now that we have a pretty good sense, like we feel pretty confident that it's working, or at least I do, because I'm the one typing. Maybe it's harder for you. We want to make sure that we set up all of our z counts correctly. Okay, so how do we do that? I'm going to need to think about that for a minute. So what we're going to do is iterate through this array. one by one. In this case, this isn't really related to the project you're doing, but I don't know, since I'm here, let's go through it. So what I want to know is, let's look at each word's z count. Let's see, last z count. So we're going to keep track of the previous thing we looked at, z count, and the current z count. Equals z count of words I. All right, so I'm looking at the current word z count, and if the current z count is greater than the last z count, in that case, then let's see. Well, then that means that I have more z's than my predecessor in the array. So I can say my z's less than me, num words less z's equals I, right? So if I'm in position, say 4, that would mean 0, 1, 2, and 3 have num words less than z. That's the number of words that have less z's, and so then we can say fewer z's count dot put put words I num words less z's, right? The idea is that, like, if I have more than my predecessor, it's that. Otherwise, if that's not the case, then I guess there's the same number as the one before me. So what is this? Else num words less z's equals fewer z's count dot get words I minus 1. So I have the same number as the person before me, so I can say fewer z's count, put words I, num words less z, something like this. Actually, how about this? All right, num words less z's. Okay. So in other words, I get the current z count, I remember the last z count, and if the current z count is greater than the last z count, the number of words less than me is I, otherwise it's just equal to my predecessor, and then I will do, I need to keep track of the fact that last z count is equal to the current z count for the next iteration. And now we just need to make sure we cover the case at the very front. I guess this should start at 1, really. We should start by saying fewer z's count, put words 0. Obviously should just have 0 things or less than that. So we'll start 1 over. And this should work. Okay, I have a suspicion this should work. All the little details here don't matter, right? Again, this is all, this is specific to this weird problem I've made up, not the project. Okay, so that's why I raced through it. I don't really care too much that you understand it. You're welcome to think about it if you'd like, but whatever. The important point, though, is just that we're updating this map. We've created a helper method that updates the fewer z's count map using sorting, okay? So when it comes to project 1, when you guys are doing yearly record, something like this is probably not a bad idea, and then that you won't have to have all this complexity, because our thing's a little stranger, okay? Sort words by order of number of z's. Okay. So let's see what happens when we try running this. Okay. Surely there's something broken. I is already defined. Of course. I don't know. Okay. I'll call this count. This is a little kludgy. I'm sorry. Okay. Last z count. Okay, so we try running it now. And it's working. Okay. So what happens is every time we put, all right. So even if, that was super fast, but yeah, little details didn't matter. So whenever we put, every time we put, we update the entire map. Now the problem is that the put operation is going to get slower and slower and slower. So what I have here will not pass muster for that 0.1 bonus points. All right. That is a little unfortunate. But more unfortunate is that if I was doing this this way, input, that is updating the rank map input, or whatever you want to call it, that means that it will be too slow to use the really big data sets, and you won't be able to produce all those nice plots that I want you guys to be able to do. Let's see. Well, you know the plots, right? Like this the nice ones down here. These things won't work if you have a put method this slow, right? It'll take too long to read the entire data set. So now we have one last thing to do, which is make put fast while keeping rank or fewer z's relatively fast. Okay. So how do we do that? Okay. Well, the trick is we don't actually need to call this every time we put, because as you may remember, let's say we do put times 1 million. All right, we put in 1 million put calls, and then I just do rank times 10,000 or whatever. I wasted a ton of effort, right? This means the way we have it right now, we update the fewer z's map 1 million times. But really, I only need to update it that the last put. Okay, it doesn't. I mean, imagine that our yearly record weird, that it's, you know, a magic box, and you can put stuff inside the magic box, and then you can ask the magic box, hey, yearly record, how many things have fewer z's then? This is a blee blah, and it'll count that up for you. And it doesn't actually have to have the answer ready at a moment's notice at all times. It just needs it so that if we look at the time requirements, it just needs to be that these on average must be fast, but any particular call can be slow. Okay, so if you look in the spec for the word frozen, you can see that described in more detail. Again, I'm assuming that already makes sense to you, but we only need these on average to be fast. So here's my proposition. Rather than updating the fewer z's count in put, let's update it in rank, okay, or in fewer z's. I keep giving away the secret. This is basically rank, of course. So what we could do here is say update fewer z's count. Okay, so if we run this should still work. But now fewer z's is slow, because now this thing right had. So if we think about this new way we just did it, rank 10,000. Now these are all super slow. This is fast again. But now these are all super slow. So how do we get this? How do we get this? This is our goal. How do we get it so that rank is on average fast, but sometimes slow? Well, it's actually not so bad. What I can do then is basically say that, what do we really want to say? We want to say if needs updating, all right? If needs updating, then do all this stuff. And only under that condition. All right, so I'm not going to give away every secret, but let's just say I have private boolean needs updating. Let's say that's always true, okay? So I run this now. The code should work fine. Now the trick is just that we don't always need updating. I mean, I can say needs updating to be false here. And I don't know, maybe I'll leave a little mysterious from there. And you can think, what's the one more thing I need to do? What's the condition under which we need to set needs updating to true again? And I'll call it a day there. So I hope that was helpful and not too intimidating. But yeah, that's the, I guess, more or less state-of-the-art way of doing this. Now, for those of you guys who are curious, is there a better way? Is there some way that I can somehow ask this tree map, for example? Can I ask this tree map, how many keys do I have that are less than something? It's not easy, and unfortunately, I don't know why this is, but the Java tree map doesn't quite do what we want. What we really want, in case you're curious, would be a rank statistics tree, order statistics tree, sorry. So if you have an order statistics tree, this is what you would really want, but we don't have it. All right, so we're kind of approximating that. So I hope this part of the assignment was more inspiring and challenging and less stressful, and I hope that this video has helped make it more that way. So that's the story.